All right, great. Well, we'll get started then, and so let's talk statistics. Okay, I love statistics. I'll write that up here. Okay, so this is it's a great class. Well, of course I think that. But when I took my introductory statistics class as an undergraduate student, it literally changed my life. Okay, I was an engineering major at the time. I finished my degree in engineering, but after working for a couple years, I decided to come back to graduate school and study statistics. I completed my PhD in statistics here at UCLA, and now I get to teach, which I love doing. And I get to teach statistics, the subject that I love. So, I know many of you probably have not had the best experience with taking math courses or things of that nature. Many of you have had good experiences. And so my hope is that at the end of this course, you'll at least have an appreciation for the subject of statistics, and perhaps a few of you will actually fall in love with the subject as well. So let's begin and just start off with the question: why do we study statistics? Okay, and I'm hoping those of you in the back are able to read the screen. If not, I encourage you guys to move a few seats forward. There are plenty of seats in this lecture hall, so the entire class could fit in the first 5 rows if they wished. Okay, if you guys wanted to. It would be quite crowded, but you could. Okay, so why do we study statistics? I argue that we study statistics to gain a better understanding of the world around us, and in particular, statistics allows us to make conclusions based on limited data. Okay, and I must preface my lectures by saying spelling is not my strong suit. Okay, I'm much better at statistics than I am at spelling. So as the course goes on, you might catch several spelling mistakes along the way. Please forgive me for doing so. Yes. Yes, so my lecture is being recorded on my screen, and assuming the computer does not glitch out, occasionally it does, but assuming it does not encounter any problems, I will upload these to YouTube. I will post links to the videos on the course website on Canvas, and I also save these slides. And I will upload them to a image sharing website. Okay, so everything is there. If it's not an excuse to miss class. I do take attendance on some arbitrarily selected days. Just by the way attendance works is at the end of the lecture, I pass around a sheet for you to sign in. Okay, and so you might come for the quiz, but if you leave early, and you're not around to sign the paper at the end of lecture, you're not going to get credit for attendance, okay? And you have to be here to get credit for attendance, even if you have a good reason for not being here. The attendance points are given for being here, okay? So, you know, even if you have a good reason for not being here, if you have a good reason for missing a quiz or something like that, you can take a makeup quiz. All makeup requests are handled through my administrative contact here. This is worth taking a little pause here. So if you read the makeup policy, this will cover everything. So my administrative contact for UCLA Extension is Sue Kwan, okay? You are going to email her explaining why you should be getting a makeup quiz or makeup test. She'll most likely ask for some kind of documentation for the reason, you know, if you said you're sick, you're going to need a doctor's note saying that indeed you were sick. And then, and once she approves that request, then you'll schedule a makeup test with her. If any of you have any kind of disability, whether a physical disability or a learning disability, whatever it might be, you might be entitled to certain accommodations, okay? And if that's the case, the person you need to contact is Pam Head in the Students with Disabilities office. Let me see if I can find her contact information. Where did it go? Maybe it's in the syllabus, sorry. Okay, well, I'll check here. Okay, yes. Services for students with disabilities. Contact this group, okay, or these people, and they will ask for kind of documentation of your disability and make appropriate arrangements for you. Okay, so again, if you miss class for some reason and you have a good reason for missing class and you can kind of provide documentation that this happened, contact my administrative contact, Sue Kwan, who can arrange a makeup for you, and if you have any kind of disability, please contact the Services for Students with Disabilities office. We have a question right here. Yes.
Yeah. Will the makeup happen in class? Or
no, you will arrange it with Sue Kwan, who will give you the location and time that you can take a makeup. Yes. So I hold office hours before class, okay? Generally from around 6:15 to 7 o'clock. That's when I hold office hours. Next week will be an exception. After class, I'll stick around for those of you who did not pass the preliminary test the first time. Okay, so next week, if you didn't pass, I'll stick around after 10 o'clock. To administer the preliminary exam, kind of give you your second chance to take it, okay? But other than that, I generally do not stay after class, okay? All right, so here we are. Why do we study statistics? So I say statistics allows us to make conclusions based on limited data. Okay, so what does it mean to make conclusions based on limited data? So imagine, so as you do any kind of scientific discovery or something like that, we often have a research question, okay? So for example, we could say, the question could be, is a new experimental medication effective at treating lung cancer? Okay. Now, in order to answer this question, this would require some kind of experiment where we administer this experimental medication to people who have lung cancer. Okay, so this will require some kind of study. Oops. Some kind of study or experiment administer the medication to patients with lung cancer. Okay, and we want to think of something called a population. Okay, and so a population would be everyone who is relevant to answering the research question. Okay, and so in this case, the population would be everyone who has lung cancer. Okay, so in our example, okay, this is everyone. All right, and the problem is, though, is that the population, if we try to think of everyone who has lung cancer, this population is far too big. Okay, this population is too big for us to try to study directly. Okay, so it's too big for us to study directly. So what we have to do is we have to study a sample. We can't study everyone who has lung cancer. We have to pick some people. Okay, we have to, maybe we can study 50 people who have lung cancer. Okay, because there might be thousands of people out there who have lung cancer. There's just too many people. And so because the population is too big, we will not study the population. Okay, and instead, we will study a sample of people. Okay, and so a sample is a group selected from the population. It is a smaller group Okay, so just kind of schematically, here's a little picture. We've got the population. It's this big entity. This is too big for direct study. Okay, and so instead we just take a little piece, okay, just a little piece of the population. And we're going to study this thing. This is called our sample. Okay, we observe our sample. So this is an eye. Okay, we observe and study the sample. Okay, and based on what we see in the sample, we try to make conclusions about the population.
But that would be very abstract.
Okay, hang on. Let me. Okay, and so this process of observing a sample, and based on what we see in the sample, we make conclusions about the population. This is called statistical inference. Okay.
So we always be working with population,
So we can almost never work directly with the population. Only in rare circumstances can we work directly with the population. We're almost always working with a sample. Okay. So in order, if we want the conclusions from our sample to be valid about the population, right? So we're looking at the sample and we're going to make conclusions about the population based on our sample. If we want our conclusions to be valid, our sample must be representative of the population. Okay? Conclusions based on the sample. Okay, so if we want our conclusions based on the sample to be valid about the population, our sample must be representative of the population. Okay, and so, we do stuff like this, and, if you've been watching the news at all, you see there's a lot of election stuff, okay? And prior to right now they're doing the primaries, right? So the Republican Party is trying to pick who they want for their candidate, the Democratic Party is trying to pick who they want for their candidate, and so, they go from state to state, and the states vote on who they think should be the candidate. And prior to the actual primary election, you see stuff about so-and-so has this kind of lead in the polls. They'll say, like, so-and-so is polling at this. Well, how do they know? What are these polls based on? Okay? Basically, when you see an election poll, they don't have the election results, right? The only results that matter are the votes that are casted during the actual election. Okay, those are the only votes that actually matter in determining who's going to be the candidate to represent the party. Those are the only votes that matter. Prior to that actual election, you have people trying to predict or guess what those results are going to be. Okay? And so what they do is they survey people, and they're hoping that this people they survey represent or will give them an idea of the people who will actually vote. Okay, so the people who actually vote, maybe let's say there's 100,000 people in some state who will actually vote in the Democratic primary. Okay, so if we're talking about a smaller state like, I don't know, Wyoming or something like that, maybe there really is only 100,000 people who will vote in the Democratic primary, maybe even less. Who knows? Okay, and prior to that, no organization. A lot of times these are done by different research organizations or news organizations. No organization is going to actually try to figure out exactly who those 100,000 people that are going to vote will be and try to survey all of them. What they might do is they might survey 500 people, okay? And what they're hoping is that these 500 people that they've selected are a good representation of the 100,000 people who will actually vote, okay? And so based on what they see in those 500 people, so if in those 500 people it says candidate A wins 60% of the vote and candidate B only gets 40% of the vote or something like that, then what they're hoping is that by looking at these 500 people where it says 60% goes to candidate A, they're hoping that can then apply to the general population of 100,000 people and say, okay, something around 60% of the general population will also go to candidate A, okay? But of course, there's some flex there, right? These 500 people are not necessarily representative, okay? And even if it were a good representation, who knows what's going to actually happen on election day, okay? So in our class, we're going to learn kind of a lot of the process and the thinking that goes into this dotted line of statistical inference. How are we going to make conclusions about the population based on the sample? Okay, so all of that I just said, I'm going to kind of write down in a kind of a short, succinct fashion, but that's kind of an application of statistical inference in kind of the real world here. Okay, so what we have. So this will be our population will be, all voters in, I don't know, we'll say Wyoming's Democratic primary. Okay. This thing is, too big and will only be known on election day, okay? Okay, so, but before election day, we have a sample, maybe a sample of 500 Democratic voters. Okay. So this is a poll. Okay, in the poll, okay, so in the poll, candidate A gets 60% of the vote, okay? So with statistical inference, okay, based on our poll results, we anticipate that about 60% of all voters in the population so this would be like 100,000 voters will support candidate A. Okay, but of course, we expect there to be some fluctuation in the result, okay? And we don't expect our poll results to perfectly predict the actual election results.
Professor,
Yes.
is that part of the, what is it called, the uncertainty from statistical inference?
Yeah. So uncertainty is just going to be a part of, yeah, so statistical inference is kind of the math and trying to determine how much uncertainty there is, okay? So, but we do not expect our poll to perfectly predict the election results. Okay. All right. But if this sample of 500 Democratic voters, if this is assuming our sample is fairly representative, okay? If the sample was not selected in a representative fashion, okay? Let's say they just went to a college and asked 500 people at the college or the university, who do you support, okay? Well, their answers are going to be, the results of that poll will be biased, okay? Biased meaning not representative of the actual population, because if they surveyed people from a college or university, they're going to get too many people who are young, okay, between the ages of 18 and 25. They're going to get too many people between people who are 18 and 25, and that group of people does not necessarily look like all people who can vote, okay? And so the results there are going to be biased, okay?
Professor,
Yes.
so that like lead the results to be skewed?
Okay, so skewed, in statistics, skewed takes on a very specific definition, and so I hesitate to say yes or no. I'm going to just stick with the word biased, okay? But perhaps in day-to-day colloquial language, you can say skewed, but in statistics, skewed takes on a specific definition, so I don't want to use that term. Okay, can I flip to another slide here? Yeah. Okay. All right. So what we're going to say is, if a sample is not representative, of the population, it is said to be biased. Okay, so biased will generally mean too many of one group or type, or too few of another type. Of a different type, of a different group or type. So if we're talking about people and you surveyed the local university, then you're going to have too many young people and not enough older people, okay? All right, and so one method that should, okay, but not guaranteed, to give a representative sample is simple random sampling. Abbreviated SRS. Okay, so this should give you a representative sample. And the way we get a simple random sample is we start with a sampling frame. I'll say start with sampling frame. Okay. Ideally, a sampling frame is everyone is a list of everyone in the population. Okay, but this is actually a difficult thing to do. To get a list of everyone in the population, that's actually quite difficult to do. Okay, so I mean, for example, if I told you I want to conduct a simple random sample of people in Los Angeles, so that means our sampling frame would need to be a list of everyone who lives in the city of Los Angeles. Okay, this is quite a challenging thing to do. I'm not sure how we could get a list of everyone who lives in Los Angeles. Are there any ideas? What could work? Census. Okay, so you know, maybe the census would be willing to share their information. They probably won't, but even if they did, okay, the last census was taken in 2010. Okay, that's 6 years ago. In those past 6 years, a lot of people have moved to Los Angeles. A lot of people have moved away. A lot of people have been born. A lot of people have died. So that census data is going to be outdated, so it will not be a current list of people who live in Los Angeles. And as hard as the Census Bureau tries, they inevitably also miss people who who don't have permanent addresses or just have maybe slightly unusual living situations. Okay, so. So this is a difficult thing to do. You know, maybe we can say, well, we can somehow get a phone book, but the phone book is not going to have, probably many of you are not listed in the phone book, okay? Maybe we can go on Facebook and somehow obtain their, you know, geolocation data if they were to share that with us. But that's also going to be very inadequate because many of you may or may not have Facebook. Probably most of you have Facebook, but there are many people in Los Angeles who do not have Facebook. Probably the closest thing that I can think of, and this is probably just data that we do not have, we will not be given access to unless you're the NSA or something, would probably be all cell phones that ping a tower that's located in Los Angeles. That will probably give us something that's the closest to a picture of who's in Los Angeles, but I don't know how anyone who's not the government can get a hold of that information. Maybe the government can or can't even get that information. Who knows? And that's only going to give you kind of a list of cell phones, and some people have multiple cell phones and some people don't have any. So it's very difficult to try to get a sampling frame. But assuming you have a sampling frame, okay, so that's where we start, okay? You start with a sampling frame, and then with your sampling frame, all you do is you select individuals one by one at random. Okay, and this will produce, this means all people in the sampling frame, or all individuals have an equal chance of being selected. And all possible samples have an equal chance of being selected. Okay, so what does it mean, all possible samples? Just think of lotto tickets, okay? Every number, so I don't know how many numbers are in the lotto pool, like 60 of them? I have no idea. Let's just say there's 60, okay? Every number 1 through 60 has an equal chance of being selected, but then also I don't know how many numbers show up on the lotto ticket. 6 numbers? Something? Okay. So all combinations of 6 numbers also have an equal chance of being selected. The ticket 1, 2, 3, 4, 5, 6 is just as likely as the ticket 9, 17, 24, 36, 45, 52, okay? Both tickets have the exact same probability of being selected, okay? So, by the way, don't play the lotto. It's just a waste of money, okay? I'm telling you as a statistician. Okay, why don't we take a short break here at 8:30? We'll take a 10-minute break, and then we'll come back and we'll finish out chapter 1 and get into chapter 2.